Hi, today we're going to talk about congruence, which hopefully is a term you've heard before, but I want to clear up some things about the difference between really what it means for something to be congruent and for something to be equal. Mainly that is that if two things are congruent, then that means we're talking about some sort of shape or object, whereas when I'm talking about things being equal, we're talking about numerical values, so measurements or something. So for instance, if we take a look at these two triangles, and let's pretend, let's just assume that I know that triangle ABC is actually congruent to triangle DEF. First of all, the fact that I'm even saying that, I don't say that these two triangles are equal. I could say that their areas are equal. I could say their perimeters are equal. Right? But I can't say the triangles. The triangles themselves are congruent. Okay? And we're going to talk about exactly what it means for figures to be congruent in a second. But I wanted to make sure we really classify the difference between what these two words mean. And let's take a look at like different parts of the triangle real quickly. Okay, so for instance, maybe I want to talk about sides. I could say, for instance, that side AB, if I write the segment across it, right? So segment AB would be congruent to segment DE. But the length of AB is equal to the length of DE, right? Because here I'm talking about a measurement, a numerical value, and here I'm talking about an object, a part of a shape. Okay, so along that same line, knowing that these two triangles are congruent, I could say, for instance, that side BC is congruent to side EF, or I could say that the length of BC, or measure BC, is equal to measure EF. And of course I could say the same thing about these two sides, so I could say that AC, side AC is congruent to side DF, or I could say that length AC is equal to length of DF. Okay, the same thing can be said about angle measures, right? I could take, for instance, this angle up here is going to be congruent to that one. So, and also while we're here, we should talk about different ways we can name angles. So I could say that angle A is congruent. Hopefully we know that this symbol means congruent, by the way, is congruent to angle D. But I also want to make sure, well, compared to measurements, right, we would write measure of angle A is equal to measure of angle D, because that's a numerical measurement. But I also want to use this opportunity to make sure we know that we shouldn't always just use one letter to name an angle. I really want to usually use three. So for instance, a better way to write this statement here would be to say something like angle, so I don't have my pen, angle maybe BAC, right? This angle is congruent to angle EDF. Okay, we usually use three because sometimes our diagrams, one letter is not enough to distinguish which angle we're talking about. Okay, so along that same vein, we could say something like angle ABC is congruent to angle DEF. That would be down here and down here. Or again, I could say the measure of angle ABC, it's not going to be congruent, it's going to be equal to the measure of DEF. And I don't need to do this anymore, I hope. I just want to make sure that we are clear about the difference and when we use the symbols for equal and congruent appropriately, because even though they kind of mean the same thing, they're not the same thing. They're both talking about equivalency, but not referring to the same types of objects. Okay, so let's speak a little bit more about what it means for two figures to be congruent. And I want to kind of flash us back to what we talked about a couple units ago with rigid transformations. We talked about the fact that if a rigid transformation was a transformation in which size and shape is preserved. right? That was our definition, and we knew there were three types of these transformations. We had translations, we had rotations, and we had reflections. Okay, so one way that we can define congruent figures, although even in maybe as early as elementary school, surely by middle school, you've talked about the idea of congruent figures means same size and same shape, right? Same size and shape. But I want to kind of offer this other way of thinking about it as two figures are congruent if you can take one of them and do one of or a combination of these three transformations and you get the other figure, right? And then of course if I'm talking about polygons or things with sides and angles, the result of this is that if I do have two congruent figures, let's look at this bottom statement here. If I have two figures that are definitely congruent, then I know that any corresponding angles are going to be the same and any corresponding sides must be the same. On the flip side of that, well, let's look at an example of that real quickly before I go to the flip side. Okay, so let's say we have these two quadrilaterals and we know we are given the fact that they are congruent. So the fact that they're congruent means that we know that their corresponding parts must also be congruent. And hopefully this is pretty self-evident, right? But we should know right away, for instance, that the measure of angle SRU, which is down here, has to be congruent to the measure of BAD, right? So it has to be 90 degrees. Those angles must be congruent. We should know also that this angle up here is 90 degrees because it corresponds with angle B. Okay, and one way you can tell corresponding, one visually, but also with how we write them, the order. So the way if this is written A, B, C, D, then that means angle A must correspond with angle R, and B must correspond with S, and so forth. And in terms of these being congruent based on our transformation definition, hopefully we can see that, like, if I were to maybe rotate this figure 90 degrees in this direction and then flip it, reflect it over a line like this, that it would in fact create this this figure over here. But anyways, we can still find out some more things. For instance, that the measure of angle ADC down here has to be equal to this angle here that's RUT, right? So that must be 110 degrees. And likewise, the angle T, that angle T here, which corresponds with C, that we could say something like the measure of angle BCD is equal to 70 degrees. By the way, the fact that when I use three letters to define this angle, the order that I choose the angles does not, right? So I could also have called this angle DCB, that's 70 degrees. When it does matter is when I'm making a congruent statement. For instance, if I wanted to say that BCD was congruent to an angle, now the order matters, right? If I'm going from B to C to D, this should correspond with STU. Right, so I would say BCD is congruent to angle STU. Whereas if I wanted to make a statement about, I'll change the color real quick, maybe I won't, between angle DCB, then that is going to be congruent. Right, if I change the order, then I'm going to have to now talk about angle UTS. So beware of that. Last, I know I'm taking a long time here, but we also can make statements about the side lengths here, right? So for instance, that the measure of AB is equal to the same as the measure of SR, or RS, which is 8 inches, right? And for instance, this ST that's 11 inches should correspond with BC down here. So we could say like that BC is equal to 11 inches, and so forth. The point is all these corresponding, so like AD, I haven't mentioned that one. that AD should correspond with RU, and so I could make the statement that RU is equal to 6 inches. Notice that I'm writing equal signs because RU and AB and BC are measures. They're numerical relationships. Okay, so real quickly, let's just talk about the converse of the statement we just referred to, which means the opposite order. So, for instance, if I knew that I had all this information about these two triangles, I see that these two angles are congruent, L and R. I see that K and Q are congruent, J and P are congruent. I also see that they have 3 corresponding sides are congruent. So the fact that I know that the corresponding sides and angles are both congruent, I can then draw the conclusion that the figures themselves are congruent, and I can write a congruent statement about them. And so the order is important here. So for instance, if I'm going to say triangle JKL is congruent to something, I have to make sure that the order that I state it is in the same order. So which point corresponds with vertex J? And that's P, right? So I need to write P first, and then what corresponds with K is Q. They're both 75 degrees, and then what corresponds with L is R. And you can look at that based on their angle measurements and also what's joining them. For instance, the 9 side and the 6 side should correspond with that vertex joining them should correspond with 9 and 6, right? Which would be R, which still matches up with L. So we're going to do a lot more with this tomorrow, but hopefully this makes some sense. Thanks.